Okay, so in this video, we're going to learn how to factor a pattern of polynomials known as a difference of squares. And we can recognize this pattern by there are actually three components. These polynomials all have exactly two terms, okay? And the pattern also has a minus in between those two terms. And last, each of those terms is going to be a perfect square. Okay, and what do I mean by a perfect square? A perfect square is an expression that is the result of multiplying something by itself. For example, 3a times 3a is going to give us 9a squared. So 3a in parentheses squared is the same as 9a squared. So this is a perfect square. Okay, so if it can be written in this form where something is multiplied by itself or squared, then it's considered to be a perfect square. Okay, so how do we factor a difference of squares? Well, it's really very easy. If you have this pattern, then you're going to open up two sets of parentheses, and we're going to identify, well, what is being squared in the first term? Well, a is being squared in this first term, so a is going to go in the front of each of the sets of parentheses. Now, what's being squared in that second term? Well, b is being squared in the second term, so b is going to be in the back of both sets of parentheses. And then right in the middle, we're going to have one plus and one minus, okay? What that does is, remember that if you are going to multiply this out, you would first multiply the a times the a, and then the a times the negative b. Then you would take the b and multiply by the a, and then the b by the negative b. Well, when you do that, notice these two terms. We're going to get an a times a negative b, which will end up being negative ab. And then we're going to get an a times a b, which is going to give us a positive ab. And when you add those together, you get a net result of 0. So all that you have left are these bottom two things, the a squared and the negative b squared. So that's why this pattern works. All right. So let's go ahead and identify what is being squared in this first term right here. Well, that's going to be 11p, correct? All right, now what's being squared in this back term here? That's going to be 8q. Okay, so let's go ahead and open up that set of parentheses. That 11p goes in front of both, and the 8q goes in the back of both. And then what do we put in the middle of both terms to separate them? One's going to be a plus, one's going to be a minus, and that would be completely factored. Now, whenever we're working with difference of squares, we're also going to make sure that there's no GCF that needs to come out first, or that one of our resultant factors, it cannot be factored further. So in the next two examples, we're going to have each of those situations occur. So we're going to take this to the next level. All right, so let's first start here at 16x to the fourth. What is being squared to give us 16x to the fourth? Well, of course, that's going to be 4x squared, because if we square that, we will get 16x to the fourth. And what's being squared to give us the 81? Of course, that's 9. Let's go ahead and put that in our two sets of parentheses. We have 4x squared in the front and 9 in the back. First one will be plus, last one will be minus. Okay, very good. Now, if we're observant, we will see that this back binomial is also a difference of squares, so it can be factored further. So we're going to take that and break it down just a little bit more. This binomial in front here is just going to stay in front and tag along with us while we separate this back binomial into two binomial. So what is being squared to give us the 4x squared? Well, that would be 2x. So that's going to go in the front of these two. Now, how about what's being squared to give us a 9? And of course, that's going to be a 3. So put the appropriate signs in, and we have now factored this completely. So we took this 16x to the 4th minus 81 and separated into two things, but one of those things could be separated further, and so we broke that down a little bit more. All right, in this last example, we're going to be observant and notice that 225 and 100 are both divisible by 25. So the first thing we're going to do is we're going to factor out that 25, all right, and then see what's left. Now, if we factor the 25 out of the 225, that's going to give us 9x squared y squared. And then that 100 divided by 25, I got 4 quarters in my pocket. That's going to give me $1, so that's going to give me that 4. All right, now looking at this is a difference of squares. Well, our original was a difference of squares as well, but we could factor GCF out, which was what we want to do first. We're going to keep that 25 out in front, and then we're going to open up a set of parentheses for this binomial here, which is going to be broken into these two pieces. What is being squared to produce this 9x squared y squared? Well, of course, that's 3xy. And what's being squared to produce that 4, and that's going to be 2. Okay, so one's going to be a plus, one's going to be a minus. All right, with that, we're going to conclude our difference of squares discussion, and I'll see you next time.